Hello, Math 141. This interesting problem was emailed to me. We have f of x equals 1 over x and g of x equals 1 over x minus 1. We are supposed to find all values of x for which the graph of f lies above the graph of g. So of course we can just put this in a graphing calculator and look at it, but I suspect it's going to be hard to see because of having one vertical asymptote at x equals 0 for f of x, and then having another vertical asymptote for g of x at x equals to positive 1. So let's just be safe and do this algebraically and then go look at the graph together. So the nature of this problem is telling me find the values that 1 over x is greater than 1 over x minus 1. This is what the question breaks down to algebraically. All right, I'm going to go ahead and put everything in one side. So I'm going to have 1 over x minus 1 over x minus 1 greater than 0. And now, in order for me to combine these, I have to have LCD. So I'm going to multiply top and bottom of 1 over x by x minus 1, x minus 1, and multiply top and bottom of g by x. Okay, let's go to the next page and continue. Now I'm going to have x minus 1 over x times x minus 1 minus x over x times x minus 1, and we had that greater than 0. Combining this, I get x minus 1 minus x over x times x minus 1 greater than 0. I'm going to go ahead and cancel x with minus x. So I'm left with negative 1 over x times x minus 1 greater than 0. Okay. Well, the numerator of this rational function doesn't give me any critical point or any point of interest because it's just a constant. But the denominator, when x is 0, I have a vertical asymptote, so that's the point of interest. And at x equals to 1, I have a point of interest because at x equals to 1, negative 1 over x times x minus 1 will be undefined. So I have two excluded values, 0 and 1. If I pick a number to the left of 0, let's say negative 1, and I plug that into the x's, I'm going to get minus 1 over minus 1 minus 1 minus 1. So that gives me negative 2 times negative 1. That's going to give me a positive 2. And I have negative 1 on the top. So I have negative 1/2. And negative 1/2 is not greater than 0 because, it's not greater than 0. So I'm going to put here F for false. I'm not having any solutions to the left of 0. I also know that 0 itself is excluded. Pick a number between 0 and 1, let's say 1/2. If I put positive 1/2 for x, I'm going to have 1/2 times 1/2 minus 1. So that gives a negative 1 over. This gives a negative 1/2 times 1/2 is negative 1/4. So cancel the negatives. 1 divided by a quarter gives me a positive number, positive 4. and a positive 4 is greater than 0. So what I'm going to do, I'm going to put here T for true. I get solutions there between 0 and 1. We also agreed that 1 is not part of the domain because when x is 1, the rational is this is going to be undefined. So 1 itself is false. And let's pick a number to the right of 1, say 2. Then I have -1, 2, 2 minus 1, and that gives me -1 over, this gives a +1, times 2 is 2. So a -1/2 cannot be greater than 0. So I have false in here. So the only solution set that I have is from 0, 0 not included, to 1, 1 not included. So the solution set is from 0 to 1. We found that algebraically. So now I'm going to try to look at, let's look at the graph together. And if I go to share screen, let me go to here. Oh, cool, I have it. So notice that the red color is a graph of F, and the G color, the blue color, is the graph of G. And so notice that the graph of F, 1 over x, goes here, 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 but it does go towards the vertical asymptote. It's approaching the y-axis, but it'll never touch it. It'll never touch it, okay? And so the graph of, then it picks it up from the other side of 0. And from the other side of 0, notice that any value after 0, the graph of the red is above the graph of the blue. Let's say when x equals 1/2 right here. Look at it. The red is above this blue. When for the value of x equals 1/2, notice that the red is above this blue value, which is way down here. Now, at 1/2, don't compare this red with this blue up here, because this blue will never, sorry, 1/2 was here at x equals to 1, okay? We do have a vertical asymptote for g of x. So this blue in here will never hit x equals 1. So anywhere between 0 and 1, this red graph is above this blue graph. It would be very, very powerful if I could somehow, oh, you know what, let me, give me a chance, maybe I can do this. If I, let's see, how can I put my, how about if I say, would decimals give me x equals, say, 1? Oh yeah, look at the green one. And if I say, go to the next one and go x equal 0. So notice that x equals 0, this color, this dark blue color, at least I see a dark blue in my calculator, that's an asymptote for f. The green right here is an asymptote for g. So between this asymptote and this asymptote, look, the graph of red, which is f, is above the graph of green, which is g. Well, I hope you liked this video, and let me know if you have more questions. Thanks.